Hello guys, welcome to another episode of Xa Talk Show. Today we are going to do Wolfram language. We are going to have fun and coding a bunch of seashell stuff. Now look at these fantastic seashells. Now, there are all sorts of seashells. There's this tusk shell. Then there is this, all sort of. So we are going to do code Wolfram language, mathematics formula to model these seashells like this one. Okay, so it's about pure Wolfram language, and today is 2022, January 21st. Okay, so let's begin. So let me prepare my Emacs commands. Okay, so on the pink window you can see all my Emacs command calls and keystrokes. Okay, for example, you can look at the pink window. You can see it's okay. So let's do that. So let me show you. So let's plot this. Okay, so copy that. Go to Wolfram language. I already have it open. So you want to say parametric plot 3D, okay? And you want to give this formula, paste it, okay? And this formula, and you want to say, let's say u from 0 to pi and v from 0 to pi. For now, okay, plot it. Okay, so we have part of it. Wolfram language, fantastic. Now copy the previous input, that is Control L. Then you want to let's see, make them look nice. So this is the formula, and now let's increase from 2 pi, let's say 6. Okay, u from 0 to 6. Now it's better. Now let's say u from 0 to 20. Plot it. Fantastic. You have part of it. You can rotate. You can see. And the v from 0 to 2 pi, let's say. Fantastic. Now it's closed. Okay, now let's say not 2 pi, let's say 6. So we can see a sort of gap. Okay, this is pretty good. So that's what we are going to do. We are going to do, there's a lot of formulas, and we are trying to model all these seashell shapes. And look at this one, some of them, people cut it apart and you can see inside. So this is natural construction. It's amazing. And you can see, let me show you some of these. Open that. Okay, yeah, so, cut away view, and that, and this one, okay, those are not, and some of them are exotic. I was into seashells starting like 20 years ago. I kind of collected them a little bit, and, some of them is just amazing. So what I would like to do is to characterize them, codify them into mathematical formula, so you can have a equation that models all these variations. Now the basic variation, the basic thing about seashell is that, basically it's sine cosine. It's like so let's delete this one. We don't. Okay, so basically it's sine and cosine. If you learned calculus or analytic geometry, you all know how this works. You have sine and cosine, and formulas, parametric formulas for sine and cosine, and you trace them. So that's the basic form. But however, look at all these variations. So this is a basic form of seashell, but then you have so many variations. Okay, so actually let's let me close this. Let me do something here. So I have this URL, open, copy, close, Oh, it's on xali.org. Okay, never mind. So we want to model this by a mathematical formula, and there are many variations. For example, this is like a, normally you rotate a circle around an axis, and the circle, as you rotate, you increase the circle size, then you got that kind of shell. You increase the circle size and also you move it down along the axis, so you got this, this is the basic shape of seashell. But then there are variations. For example, this one is kind of like, instead of rotating a circle, you rotate a triangle, and you got this shell. This shell is called Thatcher shell. Amazing. Okay, and this one, for example, it got ribs like along the shell. So this is, a very interesting math exercise. For those of you programmers into mathematics for fun, this would be very fun. So when you rotate this circle along the axis and move the circle down, you generate a seashell. But every so often, periodically, you want to have them have these ribs. How would you do it? Yeah, so in other sense, you rotate the circle, but every once in a while, you all of a sudden increase the circle by a little bit, then decrease it, so you get these bumps. So very interesting to explore, to try different formulas, and for this kind of thing, the best tool is Wolfram language. Okay, Mathematica. Okay, so let me introduce you. So I talked about Wolfram language a lot, and you can get it for free since like 2 years ago. So if you just search for Xali Wolfram language, you can find all my tutorials. So you can download it for free, or you can buy a Raspberry Pi, it comes with it, or you can just buy pay it and buy it, student version or hobbyist version. Streaming. Am I still streaming? I got disconnected. Streaming health. Okay, so Wolfram language. Okay, so modeling seashells. So I have a bunch of tutorials. You can see then the difference between Wolfram language, Wolfram engine, Mathematica, Wolfram script. I explain them all because it's a bit complex. If you go to the Wolfram site, there's lots of marketing-oriented talk. So I give you a clear explanation of their differences. Then here's a tutorial about Wolfram language syntax, and Wolfram language tutorial for beginner. Okay, so you don't have to have any experience with Wolfram language, and if you are a programmer, this would be good for you as well, because Wolfram language is quite different from all other languages. From Lisp, Haskell, it's mostly similar to Lisp. Okay, it's symbolic, Lisp, and pattern matching based, which is the pattern matching is different from Haskell or Camel or other functional languages such as F#, Haskell, or Camel. So it's symbolic pattern matching, kind of like Lisp macro, but far more advanced. So I did several talk shows about Wolfram language. There's 10 or so of them. So you should check them out on the details of Wolfram language. But today we are just going to do these fun things, okay? So let's go to talk show. And okay, so we intro code formula, so we want to do that. So let's fix this. This is not looking good. Okay, so let's say 2 pi. Okay, so it kind of, so this controls how, this controls how much it grows. Let's say 10, let's say 30. Okay, so part of it is clipped. I don't want it clipped, so first of all, let's make a copy of it, and let's make it, you know, let's change the format so that it's better to be displayed in a website. So open the seashell, so show in browser. So we are going to modify it. Let me put this here, Wolfram language. Okay, so now watch this part. Show in browser, that's better. That's a full complete Wolfram language. You can just copy and paste and run it. So apparently I had some old Wolfram language packages for drawing these. Let's open them. You know, they are written like 10 years ago, more than 10 years ago. So I'm not actually certain they will run. Okay, so let's open them. So there it is, seashell. Okay, magnify. This mathematical notebook is from project Visual Plane Curves, history length. Okay, continue, revert to old styling, continue with updated styling. Okay, so this is old graphics of Wolfram language. Let's run them again. I think I'm going to get errors because do it. Yeah, render all. Okay, so show it. Yeah, no, okay, show it again, show it. Render all is the problem. Do it. Show it. Fantastic. Now let's see. Okay, so you see the code is, you know, this code is written in 2002, so 20 years ago. So you see this part, it looks pretty, but it's not supposed to be that way. So save it, and let's open the other one. Okay, this one. Let's magnify. Okay, 2002. Run it. Comments and questions. Post it, okay? Comments and questions. I want to see them. Oh, okay, so this one is spectacular. Look at that. Look at that thing. So this is what this is kind of what I'm talking about. Okay, so let's try to evaluate this. 20 years old Wolfram language code. Do it. Do it. Fantastic. So this is the one where you get bumps. Fantastic. But this is not a full thing, so we want the full thing. So let's see. 4 to 5, 4 to 10. Let's see what happens. Okay, so apparently you controls the height. Oh wow, this thing is this is a user interface problem of Wolfram language. It kind of shrinks the Okay, I think I should go on. So I'm gonna work on this offline, I guess. So let's try again. So plot points, let's remove them so it's automatic. Okay, you cannot remove the plot points because you need the plot points. Okay. Hey Scott, long time haven't seen you, Scott, the expert on CPU and GPU and C language. Great to see you again. How are you doing? I hope you are doing great. So Wolfram language, okay, so this is fascinating, So, in order to know this, to do this, actually, a lot of thinking is required. You need to look into, let's make this. Okay, so I have explanation on what these parameters do, but let's make this part, formatted like rendered like a traditional math equation. So you got things like that. So anyway, yeah, so right now we want to, so we got a formula that looks like that, that models this seashell. But this one, it doesn't, I mean, we got the basics down, but it doesn't look pretty. We want something that looks pretty like that. So that means actually it will involve several hours of coding. And before we can even do that, we need to understand the, we need to look at these equations to understand what exactly they are doing, to be able to have a nice plot. Then if you want it to look like this, with a wireframe on part of it, that means you're gonna have to code Wolfram language for a few hours. So this is something for me to do. So let's save this for now. Can you make fractals? Yes, of course. In fact, it's built in, but I'm not going to do it today because continued fraction Mandelbrot. Oh, there's a Mandelbrot set. Okay, so let me. I don't Mandel. Okay. So Mandelbrot set distance, Mandelbrot set member cube, Mandelbrot set plot. So this is the one you want to use. Let's look up the documentation. There you see it. Okay. So let's copy it. I smoked too much. That's why I've, so there it is, Mandelbrot plot. And you can also plot Julia set. So let's go to the documentation, and you can see Mandelbrot plot and Julia set plot. Copy it, paste it, run it. There it is. Okay, now can you, you cannot zoom in like that. You have to code a little bit. So anyway, because Wolfram language has close to 7,000 functions built in, so basically everything you need. Anyway, so let's get back to the seashell. Okay, so we did. So we have this one. It's Wolfram language code, and then we have this one. Now I need to clean them up. I need to do a lot of thinking. I cannot do it while doing a live stream. Can I? No, because this is a parametric formula. You have to, for one thing, I haven't really done math for a long time. So anyway, so that's what we are doing today. So let's just have fun. So what's the other one? So this one, okay, this one also doesn't look so good, but we got the basics. Now let me show you another page. Okay, so another page, what I really want to do is, by the way, if you open this, you can see this file, for example, let's save this file. Okay, save it as untitled 1 MB. Okay, save it. Now go to the desktop. So this is the file. Let's highlight the current line so you see where my cursor is. So this is the file, and if we open it, now Wolfram language source code is all just text files. So if it's text files, how does it represent the graphics? Well, it base 64 the images. So you can see here are the graphics. And also, this part, so why do you see this kind of thing? Let me magnify, row box, superscript box. What are those? Those represent this formula, this thing you see here, rendered as a math formula. But if you are a programmer, if you came from the programming background, you probably don't want this. So you can just convert them, press a button, convert them to the ASCII form. Then you save the file. You see, the source code in Emacs also changed now, but this is not the form you want. You want the real input form. Okay, so I believe that's a key. Save it. Okay, there you have it. You can see now. It looks like that. It's kind of more readable. The actual file of the notebook, and you can press a button to convert them anytime. So this is this format is called standard form. This format is called input. It's here. Cell. Convert to input form, raw input form, standard form. Okay. So this is standard form, this is input form, and this is raw input form. Raw input form and input form, they look the same, except that the source code, if you have raw input form, then it's readable like that. But anyway, usually you don't care about the, this is for, I'm talking about this thing. This is the actual notebook, Wolfram notebook format. So I'm talking about these things so that for you org-mod, Emacs org-mod users or markdown or HTML users, so you can understand how the format of the Wolfram language notebook is actually, and you can manipulate them programmatically, either using any language you want, or you can use Wolfram language. Wolfram language has lots of functions that generate notebook or control or manipulate notebook. So you can use Wolfram language to manipulate this, just like the way you can using Emacs Lisp to manipulate org-mod files in Emacs. So I have an article on how to do that, a tutorial on how to use Emacs Lisp to manipulate org-mod. Just search for it, you'll find it. So anyway, so we got this. So what's the next thing to do? So okay, so let's go to talk show. Close that. I want to plot some formulas. Okay, here. So back then, about 20 years ago, I did a lot of these explorations, and someone sent me formulas to plot different seashells. So let's do them. I want to create the images in Wolfram language and put them up. And first of all, you need to convert these formulas into the Wolfram language syntax. He's using some other software. So let's do that, okay? Math parametric equation for seashell. The following are some math formulas for seashell by Mike Williams. Okay, that's a guy. So this is 2005. So let's do them. They are based on parametric. Okay, so let's start to code them. Okay, so copy. So copy, and now let's modify them. So this is a normal way of writing a parametric formula. So you have three functions, f, x, f, y, f, z, and you have two parameters, u and v. So this is a function that takes two arguments, u and v, two parameters, and returns basically three values, a vector of three values. So a function takes two parameters and returns three values, a vector. So in order to write this, so let's turn them. Okay, hold on a second. So okay, so now we're gonna turn them into Wolfram language syntax. Okay, parametric plot 3D, and so we're gonna modify this. So this is a vector. Of three things, comma, and R1, R2. So R equals to, let's say 1, okay? R2 equals to, let's say 2. So and cosine, okay, so this is, so we want to change all parentheses to square brackets. Okay, so let's do that. Okay, do it one shot, and also for sine and cosine, you want to capitalize them. Okay, so you see. So let's do that actually, and this part needs to be paren, not okay. So that is the okay. Also this part, god, there's a lot editing to do to convert these. Okay, so that is basically the formula in Wolfram syntax, and now you want to say u from 0 to 6, okay, something like that. V from 0 to 10, okay. Now I think that's it. Now delete that. Okay, copy that back to the Wolfram language. Let's paste it. Run it. Okay, so it says U and V, not U and U and V. Okay. Paste it, delete, paste it, run. Okay, so okay, this is silly. So this is, so basically the seashell is based on a torus. The seashell formula is based on torus. So what you need to do is actually to move it. So this one is not moving the circle around the line. So anyway, so drop that, show in browser. You can see this is before, this is after. Before and after. So we're gonna delete the before, we don't need it anymore. And the syntax correct, refresh, fantastic. This is just a circle, okay? So a torus, not circle. Okay, then he says blah blah blah. Then replace r with r times u pi. Okay, so is this boring for you guys? So no comment. Okay, so let's do the next one. So let's see this one. Okay, so paste it here, and okay, we have the code. Magnify, copy it, paste. We're gonna modify this radius of the tube. Okay, so there's a lot coding to do, because to convert this to a Wolfram language, syntax. There's a lot to do with this, to convert this into Wolfram language syntax. Okay, so let's show the pink window so you can see what commands I'm typing. So we are going to write. So you know, it's very tedious to convert this to Wolfram language syntax, but so what we can do is actually we code emag this on the fly. We code a command that help us turn this syntax into Wolfram language syntax, but that will take 5 minutes. In fact, I have the code from 15 years ago. I'm not sure it runs well. So anyway, so let's convert this to Wolfram language syntax. Okay, so do I have it? Replace Mathematica symbols. Okay, what is that one? Okay, not that. Okay, so anyway, so change bracket pairs paren to square bracket. That, do that again. Then you need to do that here. Then you need to do that here. Do that here. Okay, so that's the. So let's double check Wolfram language syntax, and then you need to remove the XYZ. So this W is a function, so you need to replace that by a Wolfram language function here. So you need to replace by a Wolfram language function. So yeah, so it's a function. Okay, so this is actually a lot to do. Function u so that's how you define a function. Equals to, so that's one way to write a function. The other way to write a function is and okay, there's actually a lot to do here. So here is a function. Yeah, so both of these are the same. Let's use that one. So we don't need that one anymore. So that's a function. And now you need to replace the parentheses by square bracket, okay? And now you don't want the fx anymore. And now you want to put them into a bracket, then you add a comma because this is actually a vector, represent a vector of 3. Okay, so I think that's it. Let's double check. And also, you know, these variables, you can see, you know, this you can see these variables are using capital letters, but usually you don't want to do that in Wolfram language because Wolfram language built-in functions start with capital letters. So yeah, for example, that n is a built-in function. You cannot do that. You know, that's why it's blue in XAR Wolfram mod. That's what I'm using, XAR Wolfram language mod. Let's just say Cn, okay? So replace all capital N by Cn just for now. Okay, do it. Let's get this to run quickly. Okay, now let's shrink. Okay, now this part is the original and here is the new. Now we want a parametric plot. Okay, and put this formula there, and U0 to 6, V0 to 10, okay? Copy it. Paste it, run it. Okay, so okay, it looks like it's a shell, it's a seashell, all right. So tedious. Okay, so we got this so let's remove the original here. So this is our new formula. Let's now again, you can make it, you know, into a render it into a formula. So anyway, so let's put the code back, go back to browser, refresh. So this is original, this is new. You know, you can just copy that and paste in Wolfram language. Now let's delete the original. Okay, now syntax correct, refresh, fantastic. Okay, so this is for my website. So I need to go through each one of them, and also add a result picture of the thing. And you can see this. You know, if I really want a pretty picture, this is not good enough because you need to increase plot points and you need to get rid of this clip. So let's try it, okay? So plot point, let's say 55 to get rid of the kinks. So now you see, now it's much smooth. You still see some kinks. You see, you can still see some kinks there. And also this double line, is no good. You know, possibly that happens because you have overlap or something. So you need to tweak the parameters and so on. So let's see, let's say 60, okay, let's say plot point 60. So there's a lot tweaking to do, and now it's too big, and you don't want this clip, you see. So you want plot range all, so you want to give it an option. Okay, do it. Fantastic. Now it's beautiful. Now it's beautiful. Now, however, you see, I don't like the color, so we need to change the color. Also, this double line is still there. So you have to figure out why this double line occur. Okay, so now let's make a copy of the previous input. Let's modify it. Let's add color, okay. I'm not sure what is the color function. Q, okay, yeah. Okay, this is gaudy, but I don't like this kind of gaudy. Okay, so plot function. Color function, rainbow, temperature map, let's say. Okay, so let's magnify. Now it's much prettier. Fantastic. Okay, so we did one of them. Let's just do this, okay, just temporarily. So we make a copy of this. Wait, we screenshot this thing, then we go to Emacs, show in browser. So that one should be this one, periwinkle. Okay, so this one is supposed to be periwinkle. Okay, so hold on a second. So I need to create a directory named I. Okay, close it. Then move the image here. Back to browser, refresh. Fantastic. Fantastic. Okay, any comments and questions? You know, so that's what we are doing. So this is one of them, periwinkle. Now, which one is periwinkle? Let's see. Let's get back to this one. Wait, no, this one is called Window Trap. Now, which one is periwinkle? Let's see. P-E-R-I. No, I don't have periwinkle. Okay, so let's search Google. Let's see if what does periwinkle periwinkle seashell. Yeah. Okay, so this looks like that. That's periwinkle. Now, so this one is top shell, amazing, extremely beautiful, amazing. You know, notice that it's kind of flat. So to generate this, you rotate a triangle around the axis. But meanwhile, not you rotate a triangle around the axis. You know, a triangle around the axis, and meanwhile you move the triangle down. But besides that, you also move the triangle away from the axis. So that way you get this cone in the middle. So there is a formula for top shell, I believe he gave. So we have to do that. This one, this one. But the editing to convert this to a Wolfram language syntax is very tedious. So in order to do, there are a lot more, like 10 of them. So in order to do that, I have to write a Emacs command to help me. So I can press one button and it converts them. That we do that in another day, I guess. But right now, let's just try to see some more fun seashells. So okay. So we haven't found out what's a periwinkle. Now look at this one. This one is another one, quite different. So this one is tiny. Okay, this one is like very tiny. And this one, the funny, one of the funny things, this one is called tooth something. Yeah, tooth shell. The vernacular jargon for this shell is tooth shell, but because it looks like a tooth. So I wanted to. So which one is periwinkle? And also this one, so many spectacular ones. So this one is called Nautilus, paper Nautilus shell. I have this somewhere in a box. Somewhere in a box. I should, next time I do this video, I should take them out and show you. This one is amazing. This one is just like paper. That's why it's called paper Nautilus shell, because it's so lightweight and fragile. It's just like a piece of paper. And it's like semi-transparent. You can see it. It's about this big. It's amazing. It's beautiful. Paper Nautilus. Okay, so, and there is snail, and there is this exotic one. Okay, but periwinkle, did we find any periwinkle? No, never mind then. Never mind. But some of them, I truly love these, their shapes. So, okay, let's go back to the code. Okay, so let's maybe do one more. So let's see something interesting. Cone shell, wrinkled periwinkle. Maybe let's do that one. Which one is this? So any questions? Do you have those command logs with the files? Do you ever look back at them to see what you did? What do you mean command logs with the files? What files? So I talked for 50 minutes now, and maybe that's it for today. So yeah, so that's it for today. So I want to do some of the interesting ones. So let's do one more, okay? Wrinkled periwinkle. Let's do that. Okay, let's do this one. Okay, so here's original. Let's put original in a comment and paste it here. Here is where we modify it. Change n to cn. And now let's repeat this tedious process again. Okay, and so again we have a function. This time let's write them as function of u. Okay, yeah, it's not okay. Let's just get this to work. Yeah. Number of turns, radius of the cube. Remove the backslash slash. Okay. Okay, then parametric plot 3D. Add the formula. And u and v, let's copy from here. Okay, so that should be it. Paste. Do it. No. Something is wrong. Okay, so oh, W. Okay, so W, yeah. W needs, W is a, it's supposed to be a function, but right now it's not written as a function. But anyway, that's, let's just get these two. Let's focus on the fun part. Not working, so yeah, okay, let's change the W to a function. Okay, W is a function, so okay. Double check one more time. Cosine sine a power. Okay, so double check. Copy that. Copy. Back to here. Paste. Evaluate. Yeah. Oh, pi is the problem. Pi needs to be capital. Because remember, every built-in symbol in Wolfram language start with capital letters. So when you have lowercase pi, it doesn't know what it is. It just think of it as a undefined variable. Do it. Oh, fantastic. Now let's magnify this thing. Let's have a look. Okay, wrinkled, periwinkle, something like that. Now plot points, let's make them, copy that and paste it here. Do it. Oh, beautiful. This thing is beautiful. Fantastic. Now let's increase the plot point double at 160 per parameter. Wow, it's taking some computation. Now let's turn on. Let's see how much memory and stuff it's using. CPU and GPU. Okay, it's taking some time to compute. Coffee and milk. Comments and questions. That's it for today. Fantastic. Okay, this is great. This is great. So let me do this. Let's do this. Okay. Let's put this on my website, and that will be it for today. Fantastic. This beautiful thing. Let's see what's the best angle to view. You know, you need multiple photos. Without animation, you need multiple photos because you cannot see the full glory. So, but for now, let's just copy that. Do a screenshot of this. Okay. And now back to here. Okay, so here's the code, and remove the original periwinkle. And then add an image. Fantastic. And color, syntax color the buffer. Show in browser. Fantastic. Wait. Why is that? Did I delete some parts? Yeah, okay, so... Oh, here, yeah, that's right. So, remove this part we no longer need. Fantastic. That's it. Thank you, guys. Hey, thank you, Scott, for coming by. Okay, so if you like my stuff, you know, pay me. And actually, so I have some news I want to share. So the Wolfram language, the Wolfram, you know, the XA Wolfram language mod, I'm going to release it to, it's going to be free. So, and I want to say, you know, the Wolfram language is, you know, I'm sponsored by Wolfram Research. So I think I'm going to release the, let me show you. Okay, so XA Wolfram language mod. So here's the code, 2,500 lines. I think I'm going to put it, you know, probably on GitHub or something. So it allows you to code Wolfram language in Emacs. Okay, bye guys. So I'm shutting down. I'm shutting down in a minute. So fantastic. Okay, so close that, close that, close that, close that. So, you know, there's huge amount of things to do. You know, I already spent 1 hour on this, but you can see how much time it will take to make, you know, this Wolfram language mathematical model photo for each one of these shell. And today we only we just touched the surface. We just showed some pretty graphics using the built-in parametric plot 3D. But if you really want a nice plot like that, it involves a lot more coding. So it's gonna be few days worth of coding, a week to do this. So that's what I have to do. Bye, guys. Hello, Justine. You late? Yeah. Bye.